Alright, this is going to be the last section of this unit, and in all the previous 4 sections we've been talking about just simplifying rational exponents and radicals, and now we're actually going to be solving them in equations. So the first example looks like this, and anytime that you want to solve a square root equation, you always want to get the radical symbol by itself. So everything that's underneath the radical stays there until after you get rid of it. But in order to get rid of the radical symbol here in this case, we need to get rid of the 3. So how do you get rid of a 3 in any other equation? You would just subtract 3 from both sides. Oops, so you're going to be left with the square root of 2x minus 3 equals 5. And then the way we undo a square root is to square it. If you do it to one side, you have to do it to the other side. So this symbol squared is going to be 2x minus 3, and 5 squared is 25. And now you can just solve this just like a regular algebraic equation. Divide by 2, and you get x is equal to 14. The really important thing about this section is that you always go back and check your answers. Because we're dealing with square roots, sometimes you'll get extraneous solutions, and you want to make sure that all of your answers are actually real answers and they can't be, you're not taking the square root of a negative number or ending up with a different answer. So you can just quickly go back and check 2 times 14 is 28, 28 take away 3 is 25, the square root of 25 is 5, and 3 plus 5 is 8, so we're good. That's the correct answer. Pause the video here and try this problem. And there's your answer for that question. You can quickly go back and check and make sure that it works. 4 times 6 is 24, plus 1 is 25. Square root of 25 is 5, minus 5 is 0. So that is the correct answer. Now sometimes you're not always taking the square root. So sometimes you're going to have a rational exponent, which we know is actually in radical form. This is the third root of x plus 1 squared. So again, you have to get the radical by itself first, and the way you would do that is to first divide by 3 on both sides. So you have x plus 1 raised to the 2/3 is equal to 4. So the way we undo this is we want to have an exponent of 1 here. So we're going to raise this whole side to the 3/2. Remember, when you raise a power to a power, you multiply. 2/3 times 3/2 is 1 over 1, or 6 over 6, which is 1 over 1. And that's what we want. And if we raise it to 3/2 on one side, we have to raise it to 3/2 on the other side. The exponents go away here. You're left with x plus 1 is equal to, if you took the square root of 4, which is 2, and raised it to the 3rd power, you would get 8. Subtract 1 from both sides, and get x is equal to 7. And you could go back and check your answer there as well. 7 plus 1 is 8. 8 to the 2/3 is 4. Times 3 is 12. So you've got the correct answer there. Pause the video and try this problem. Alright, so this problem actually had an extra step in it because you had to subtract 1 from both sides first and then divide by 3. All I did here was rewrite my radical as x plus 1 to the 3/5 instead of x plus 1 to the 3rd and taking the 5th root of that. I just rewrote it, and we've practiced that in the last section, so you're allowed to do that. Then finally, in order to get an exponent of 1, I raised this whole thing to 5/3. If I do it to one side, I have to do it to the other side. So I have x plus 1 is equal to 8 to the 5/3 is 32. Subtract 1 from both sides, you get x is equal to 31. And take a second and try this one as well. Remember, this one's already written for you with a rational exponent, so this one should be actually a little bit easier than that first problem. Take a second to try that. And hopefully you got x is equal to 5 when you did that problem out. For the next type of problem, you're going to end up with a binomial on one side. So you're going to have to square a binomial, which means you have to remember to FOIL. So just like we've been doing, you want to get the radical by itself. So I'm going to add 5 to both sides. I'm left with the square root of x plus 7 equals x plus 5. In order to get rid of the radical, I have to square it. And if I do it on one side, I have to do it on the other side. Now the left side becomes really easy. I'm going to have x plus 7 is equal to, and this is where I have to remember to FOIL. I'm going to get x squared plus 10x plus 25. Now we have an x squared term on one side but not on the other side, so they're not going to cancel. So you guessed it, I'm going to have to use either the quadratic formula or I might be able to factor. But in order to do either of those, I have to set one side equal to 0. So I get rid of my x's, get rid of my x's, get rid of my 7's on one side, and I'm left with x squared plus 9x plus 18 equals 0. And then hopefully you see that you can factor this into x plus 6 and x plus 3. So that means that x is equal to negative 6 or x equals negative 3. And just like we've been doing, you should go back and check to make sure that both of those work. So really quickly, if I plug negative 6 in for x, I get negative 6 plus 7, that's 1. The square root of 1 is 1 or negative 1. So 1 minus 5 is equal to negative 4, but negative 1 minus 5 is equal to negative 6, so that one works. Then I'm going to substitute a negative 3, and I get negative 3 plus 7 is 4. The square root of 4 is 2. 2 take away 5 is negative 3, and that's what I wanted it to equal, so that one works as well. Take a second, pause the video, and try this one. Remember, you have to FOIL on the right-hand side because you have a binomial squared. And this was really almost the exact same type of problem, so you can go through all the steps, make sure you got everything right. You get 2 answers again, and both of them do work. Alright, so this is the last type of problem that you're going to see, and this problem kind of looks a little bit more difficult, and it's going to take us an extra step to do it because we have 2 separate radicals. I can't just square one side because they're split up by a plus or a minus sign. So we're going to have to get one by itself first, square the equation, and then go back and get the other one by itself and square the equation again. So the way we're going to do this is, the first thing you're going to do is get the bigger radical by itself. So I'm going to add the square root of x to both sides. Now that means I'm left with the square root of 2x plus 1 equals 1 plus the square root of x. Now I have this by itself, so I'm going to square both sides at this point. Square both sides. Now I'm going to get rid of the radical on this side because something taking the square root of anything squared is its side, or whatever's inside of the radical. So I have 2x plus 1. I have to FOIL this side, so I'm going to get 1 plus 2 root x plus square root of x times the square root of x is just x. Now I want to get this radical by itself, so I'm going to subtract 1 from both sides and subtract x from both sides. I'm going to end up with over here x, that goes away, that goes away, that goes away. X equals 2 root x. I want to get the radical by itself, so I'm going to divide by 2, divide by 2. So right now I have x divided by 2, or 1/2 times x, equals the square root of x. And since the radical is now by itself, I can square that, square both sides. I'm going to end up with x squared over 4, sorry, I should draw a line here, equals x. I can multiply by 4 on both sides to get rid of my fraction. I get x squared equals 4x. And now from here, I want to set this equal to 0 so I can use my quadratic formula or factor. So I'm just going to subtract 4x from both sides. I get x squared minus 4x equals 0. I can factor out an x. So now I get x is equal to 0 or x is equal to 4. And you could go back and check both of those answers, and just to save time, I'm going to tell you that they do work, but you should go back and check to make sure that they do. And when you have it, after you finish doing that, you can pause the video here and try this problem. Remember, get one radical by itself first, and then square both sides. Then get the other radical by itself, square both sides again, solve for x. Alright, so for this problem, you should have gotten for your answers x equals 9 and x equals 1. And I'm going to have to scroll down because it took a little bit more room than just this page. So the first step that you had to do was add the square root of x to both sides, square both sides. So you get 5x plus 4 on one side, and then you have to FOIL the right-hand side. Then you want to get that radical by itself, so the way you do that is subtract everything else, and then divide both sides by 8. Yes, you do get fractions. So you have to get rid of, so once you've gotten rid of everything around the radical, you can square both sides again. Then, after you FOIL the fractional side here, you get this, and then when you take this, when you square x squared, you get x. And now because I had a lot of fractions and I really don't like working with fractions, that's why I multiplied everything by 4. So multiplying everything by 4 gets rid of all my fractions, but it doesn't change the problem at all as long as I do it on both sides. So then I got x squared minus 6x plus 9 equals 4x. Going to have to use the quadratic formula or factoring. So I subtract 4x from both sides. I get x squared minus 10x plus 9 equals 0. And then I can factor those. I get x minus 9 and x minus 1. So my answers are 9 and 1. And you can go back to the original problem and check to make sure that both of those work as well. And that's the end of this section, and that's also the last section in this unit. So we're going to be doing a little bit of work with this section. We'll do a review, and then we'll be having a unit test coming up shortly.